So chapter 8 is our last chapter. It is about risk measures. So what is a risk measure? So basically a risk measure is just a map, okay, mapping random variable to a number. Okay, so here we can interpret the random variable as the future payment, and we can interpret this real number as the amount of capital or reserve the company should keep so that the company has enough money to pay. Okay, so this map can be anything. Okay, so as long as it is a map from random variables to numbers, we can call it a risk measure. So there are some examples. For example, hx, this map can be, say, the mean of x times 1 plus alpha, or hx can be the mean plus some constant times the standard deviation. And in this chapter, we will specifically look at several important risk measures. The first is value at risk. Okay, so the symbol is VAR bracket x. So here we also need to specify a number called the confidence level alpha. So usually this alpha is very close to 1, for example, 99% or 99.5%. So how to calculate or how to define the value at risk of the variable x at level alpha? It is defined like this. It is the minimum amount of capital T, so that with a very high chance, okay, so the chance is greater than alpha, that the future payment or the future loss x is less than t. Okay, so here we interpret this x as the future loss. This t is the amount of reserve. So the probability here, this fxt, is the chance that the future payment loss or the future loss x is less than t. So we want to find the minimum amount of capital such that with a very high chance, say 99.5% chance, that the future amount of the payment is less than t. So this is the meaning of value at risk. So how to calculate value at risk? So if we have CDF like this, okay, so alpha is here between 0 and 1, for example, 0.995. So we have to draw a horizontal line at level alpha until this level, this horizontal line, intersects with the CDF. So in this case, we have one intersection. And then we go down, so this point is the value at risk of x at alpha. Okay, so you can see from the graph, if you put this value at risk of x at alpha back to the CDF, you can see that the CDF at this point equals alpha. And it is the only point that solves this equation. Okay, so that means in this case, when the CDF has a shape like this, which is increasing, no jump and no horizontal, so a pretty ordinary CDF, finding value at risk is very easy. You just need to solve this equation. You set the CDF to alpha and solve for t. So by solving this equation, you will get a unique solution, and that will be the value at risk of x at alpha. So later on, we will see an example. So this is the first case, okay? So the first case is like this. When you draw this horizontal line at level alpha, there's one intersection, and VAR is this point, okay? And VAR will satisfy this equation. Now, there are other two possibilities. The second possibility is like this. So this time, when you draw the horizontal line at level alpha, you can see in this graph, there's no intersection because there's a jump. There's a jump of the CDF at this point, okay? So how to find the value at risk? Remember, value at risk is defined as the smallest number t satisfying this inequality. Okay, so in order to find the value at risk, we first find out all t fulfilling this equation. The CDF is above level alpha. So you can see in this graph, the CDF will be above level alpha when t is here. Okay, so whenever t is a number here, the corresponding curve is above level alpha. And what is the minimum of such t? So the minimum will be the left-hand endpoint of this interval, which is here. Okay, so finding value at risk in this case is rather straightforward. So if we draw the horizontal line at level alpha, and you see that there's no intersection, then the value at risk is simply the point where the CDF jumps. Okay, so if you look at this graph again, This time, if you put the value at risk at level alpha back to the CDF, we will be here. We will be here, which is above level alpha. Okay, so this time it is strictly greater than alpha. Now the last case is like this. The last case is when you draw the horizontal line at level alpha, we see that there's a horizontal portion of the CDF. So the the CDF curve is flat. It's flat at level alpha. So in this case, the value at risk will be the left-hand endpoint of this interval. Okay, so that is the left-hand endpoint of this horizontal portion. Again, in this case, we try to evaluate the CDF at the value at risk, and we see that from the graph, in this case, it equals alpha. Okay, so now let's summarize what we have done. Okay, so we have defined the value at risk in this way, and then we look at three cases, depending on whether we have one intersection, no intersection, or we have a horizontal portion of the CDF. Okay, and then in the first case, putting the value at risk back to the CDF equals alpha. In the third case, again, putting the VAR back to the CDF equals alpha, but not in the second case. Not in the second case. Okay, so that means whenever the CDF curve is continuous, then we are in either C or A. So in this case, fx at the value at risk at level alpha equals alpha. If the CDF curve is not continuous, then it may be greater than alpha. Okay, so now let's look at one simple example. Suppose this is the CDF, and I want to find the value at risk at level alpha. Okay, so how to do this? Okay, so first we can see that this is a rather ordinary CDF. So from the formula, we can see that if you plot this CDF, you will see that it is always increasing, strictly increasing, and continuous. So there's no jump here, and you won't see any horizontal part of the CDF. Okay, so that means if you plot this CDF, we will get something like this. Okay, so a rather smooth curve without any jump and without any horizontal part. Okay, so we're in case A. And remember, in case A, to find value at risk, we have to solve an equation like this. Okay, we need to set the CDF to alpha. Okay, so that's why we set the CDF to level P here. So here I'm not using alpha because alpha is one of the parameters. So I set the CDF to level P. So this P is 0.99 or 0.995. And then we solve this equation. Solve fx equals P. And then solving the equation will give you x equals this expression. And this is exactly the value at risk of x at level P.